a well-designed automatic feedback control system or insulin transfer system known as KT2 control.
Here we have four key components. The first is the Arduino Uno, which is the brain of the system of the microcontroller, and a DC motor which actuates the digital motor with water release. And we have a conductivity sensor which senses the high concentration, and an L298 motor driver which operates the DC motor motion. Hence there are four processes. The first, sensing. The conductivity sensor senses the high concentration in this container, and then activation of the pump. The pump releases the distilled water to the main container, and hence there is a decrease in the concentration level. Hence this conductivity sensor senses the new concentration level. Hence there is solution. Hence the solution is we have a feedback control system which helps us to decrease our blood glucose level. Here the Arduino Uno is taken, which raises the sensor reading and take action according to it. But in this, it reads the data from the conductivity sensor and determines that the pump is on or off. If the pump is on, it will add insulin to the main container, which will decrease the concentration level. Hence, this process of controlling parameters using electronic circuit is known as a feedback control system. It has three benefits. It facilitates studies on the feedback control system and modifies the water quality management, and adapts to chemical mixing operations.
Okay. Let's come to the objective part. If a person or a diabetes person doesn't intake any sugar type of food intake, type of roti, chapati, and many more, that also contains sugar, that next morning that person didn't take any sugar at the last night, gradually in the next morning his or her diabetes level will be decreased. Okay, the person didn't know that his or her diabetes level is already decreased. After that the person will take the insulin. So what will the outcome? The outcome will be the insulin level will be decreased as it is there from the past. Okay, the symptoms of this outcome will be like trembling of the body, shaking of the body, and dizziness, and the heart rate will be high, and many more are there. The key point is known as hyperlesia. What is the disease is called? Then we have used here the normal tap water as normal blood. Here I have used distilled water as the insulin. Okay, when this range sensor will detect the value, take example of 200, means is the conductivity value. Okay, if the value will go above 200, the motor will start. Okay, as you can see, the motor is already started. Okay, when the value will decrease from the 200, the motor automatically stops. Okay, this is the objective part. Let's come to our future application. Okay, this is the main prototype object which we have made, and now we'll explain this model. When we press this left button, okay, left button for 15 seconds, you have to put your sample of the blood of your body only. Okay, after within 1 minute, this display will regulate and will sense your blood glucose value and your BP and your heart rate sensing. Okay, after that when you press this button for only 20 seconds, the sensor will detect how much of the insulin is required to your body. After 2 minutes, this display will show how much ml is needed to your body to be intake. After that, with the taking help of syringe, you can inject to your body how much ml is required, which is indicated in this display. So we are using here some miniature components such as IC, and many more are there. We are using AQ batteries and this capacitor this type of miniature, and this is the intake sensor, and here the 2x2 display. Okay,